this formula. It's going to be a resource in your resource notebook. You don't have to memorize it. It is a nice to know formula if you're ever solving quadratics and you get stuck. You could actually sing it to the tune of Pop Goes the Weasel if singing something helps you remember. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So it does go to Pop Goes the Weasel if you like to remember or memorize things. I would say that in the grand scheme of things, you can look up the quadratic formula, right? So does it have to be memorized? Not really. Something that you really should memorize in math, I think the Pythagorean theorem is a pretty important one from geometry to know that relationship on a right triangle. It's used throughout geometry and throughout trig. It's really nice to know the slope formula, rise over the run, y2 minus y1 over x2 minus x1. That's used all the way in Algebra 1, Algebra 2, pre-calculus. The quadratic formula kind of has this niche in solving quadratics. So it's nice to know, but you don't have to have it memorized. All right, so don't get too overwhelmed. It's going to help us practice this reducing radicals. And we're still using standard form. So the A, B, and C up here actually comes from the A, B, and C in standard form. And do you see the equation in here for the vertex? Do you see negative b over 2a hiding in this formula? Well, guess what? The plus or minus is coming from, you don't have to write this, but wherever that vertex is, didn't we calculate the vertex by negative b over 2a? Guess what? The x-intercepts are plus or minus a certain amount away from the vertex. So the quadratic formula is directly related to where is the vertex and the symmetry of the graph. So the plus or minus is putting, minus or plus this many units away from the vertex. So it's directly related to the vertex in standard form, negative b over 2a. All right, here is an example I wanted to show you by factoring and using the quadratic formula just to show you that the answers come out the same. So if you were really stuck on the test and you just couldn't figure out how to factor this, you could still get the solutions instead of having to leave it blank. So you could at least get a 3 or a 4 on that question. Even if you can't demonstrate factoring, you could still solve it. So this is what? A trinomial. So I'm going to use the diamond method to factor it. So I'm looking for the factors of 15 that add up to negative 8. So who can think of them? What are the factors of 15 that add up to negative 8? Yep. Perfect, right? You multiply to get the top and you add together to get the bottom. So x minus 3, x minus 5 equals 0. What are my x-intercepts, my solutions? Yep, positive 3 or positive 5 are my solutions. To me, that was a pretty quick factoring problem to get the solutions. I always like to go the easy route. I would always do that by factoring. But I just want to show you how to do the quadratic formula on the same problem, just to show you that the answers come out the same. So I have to identify A, B, and C in this standard form problem. So what is A, B, and C? 1, negative 8, and 15. So I'm going to plug all that stuff into this formula up here. So it says negative b, or the opposite of b. So that would be positive 8, plus or minus the square root. Then it says that I do b squared. So I'm doing negative 8 times negative 8 is positive 64, minus 4, because that's in the formula. And then I have to multiply a times c. A is 1 and C is 15 in this problem. So there's the opposite of B plus or minus the square root of B squared minus 4AC all over 2A, which in this case is 2 times 1. So we need to simplify this ugly looking formula and get our final answers, which should be 3 or 5 if we did it right. So order of operations, or you could use a calculator. You want to do under the radical first. And I know that 4 times 1 times 15 is 60. So 64 minus 60 is just 4. So this is 8 plus or minus the square root of 4 divided by 2. And if you want to type that into your calculator, you just type in 64 minus 4 times 1 times 15 and hit enter. And so it's telling you 4 is the answer under your square root. What is the square root of 4? 2. So then this is 8 plus 2 divided by 2, or 8 minus 2 divided by 2. Because see how it's that plus or minus sign? I think it's easier to write it as two separate fractions so that you can find the final answer. And do you see how this is 10 divided by 2, which is 5? And this is 6 divided by 2, which is 3. So I came up with the same solutions. To me, this was a lot more work, and there's a lot more room for error, but I did get 5 or 3. So the quadratic formula will get you the correct answer if you can't factor. No, I think we've been spending a lot of time on what A, B, and C are. So, and we talked about reducing radicals, so it's good that you're getting stronger with your evaluating skills. Can I turn it to the next page almost? The next one I think does not work out as factorable, so we are forced to use the quadratic formula. So this would be the only method we could use because there's no greatest common factor. There is a x, right, this negative 7x, so I can't take the square root of both sides, or else I would love to use the square root method. All right, so I'm going to actually figure out what A, B, and C are and go to town on the quadratic formula. So A is negative 1 this time, B is negative 7, and C is positive 3, and you want to make sure you're equal to 0 before you start. So look down quickly at example 3. Do you see how this is equal to 4? We're going to have to rectify that before we start solving this problem. It has to be equal to 0 to solve a quadratic with the quadratic formula. All right, I'm going to do this one with you, and then maybe you can try example 3, and we'll just set this equal to 0 first. So the opposite of B, if it helps to write, I have the formula written on the left of the board over there in case you don't want to keep flipping back and forth. So the opposite of B would be positive 7 plus or minus the square root of B squared minus 4AC all over 2A, right? Don't you hear the pop goes the weasel? B squared is 49 minus 4 times A is negative 1 this time, and C is positive 3 all over 2A, and 2A is negative 1 this time, or 2 times negative 1. So you can type under the radical into your calculator, or let's see, it's negative 4 times negative 1 times positive 3 would come out to be positive 12, right? So I'm taking 49 and I'm adding a negative times a negative. I'm adding positive 12. So I would have 7 plus or minus the square root of 61 divided by negative 2. So I can't reduce radical 61, right? There's no perfect square that is in 61. So if you want to leave your answer at that step, you technically can. And if you want to find the decimal answer, you could type it into your calculator, because I don't know where those x-intercepts are. So if you type it into your calculator, you would have 7, oh, put it in parentheses, so parentheses, 7 plus the square root of 61, oops, get out of there, divided, oops, parentheses. So I put the numerator in parentheses, 7 plus the square root of 61, I'm dividing by negative 2. And then I could just arrow up and change that to a subtraction sign. 7 minus the square root of 61 divided by negative 2. So my two x-intercepts, if I wanted to leave it in decimal form, negative 7.41 or 0.41 are my x-intercepts. It's your choice. Either leave it in reduced radical form, this one can't go any further, or leave it in decimal form if you have to graph it. but you would have to use a calculator for the quadratic formula. All right, how can I change example 3 before I start so that it's equal to 0 on the right-hand side? I would subtract 4 from the constant, right? So now I have 4x squared plus 8x plus 3 equals 0, and now I can go to town with the quadratic formula. Are you ready to try one on your own and see if you could get to the end, do you think? To try example 3 and 4? I think that's the only way you're going to start learning the formula. So I could even check for you if you have it set up right, but why don't you try 3? And I think most of us got it set up the right way. And then we got to this step, took the square root of 16, and it was 4. So it ends up being negative 1/2 or negative 1.5 when we simplify the fractions at the end. Is that what we got? You want to make sure that you conclude that there is no solution. This ends up coming out to, I got rid of my calculator now, negative 8. Is that what it came out to? Because this is 36 times 2. So this is 64 minus 72. So it ends up coming out to negative 8 plus or minus the square root of negative 8. You cannot take the square root of a negative number. So this would be a quadratic that if I graphed it, it's above the x-axis. There's no x-intercepts. So when you get a negative under the square root, this under the square root part is called the discriminant. And so that is something that's a new word for today. So the discriminant is whatever is sitting under the square root, and it's going to tell you that there's no solution. And it's also going to tell you if there's 2 solutions or 1 solution. So the discriminant is the number under the square root, and that's what it's going to show you on the next page. So the next page defines the word discriminant for you, and it tells you what the graph will look like and how many solutions there will be. Can I turn it to the next page? So this is the discriminant is just b squared minus 4ac. So it does not include the actual square root symbol. It's just what is sitting under the square root. So b squared minus 4ac, the discriminant is kind of a math buzzword, so you might see it. What does the discriminant tell you? And so here are 3 examples, and I have the graph shown down below. See how this is x squared minus 6x plus 9, and this is the graph of x squared minus 6x plus 9. See how it has 1 x-intercept? This graph has no x-intercepts, and this graph has 2 x-intercepts. The discriminant up here is going to come out to 3 different outcomes. So the first one, if I just do b squared, that would be negative 6 squared, right? 36. Minus 4 times a is 1 times c is 9. What does the discriminant come out to? It's a special answer. 36 minus 36 is 0. It says, can you take the square root of 0? Yes. But plus or minus 0 is still 0. Because in the quadratic formula, see how it's plus or minus? Well, if you add or subtract 0, you get the same answer. So that's why on the graph, there's only 1 x-intercept. So there's 1 x-intercept on the graph. So down below, so I'm kind of following this column down, if the discriminant is 0, there will only be 1 solution. So that's a special case. If you take the square root of 0, you just get 0. So there's only 1 solution that's going to show up on your graph. All right, on the next one, if you do b squared minus 4ac, b is 0 in this problem. See how there's 0 x's? B squared minus 4 times a times c. What does that one come out to? 0 minus 4 times 1 times 2 is 8. So this comes out to negative 8. Can you take the square root of a negative number? Because this negative 8 would be sitting under the radical. No. So it says how many x-intercepts are on the graph? There's no x-intercepts, right? Because I cannot take the square root of a negative number. So this is just helping you get to the fact that, hey, if the discriminant comes out negative, there will be no solution to the quadratic, right? There's no x-intercepts because I could not take the square root of a negative number. That's what the graph looks like. And then the last one is the one that you're going to find most often. You're going to get solutions, right? So when I do b squared is 16 this time, minus 4 from the equation, a is 1, and c is 3. What's 16 minus 4 times 1 times 3? So this is 12. What's 16 minus 12? Positive 4. Can you take the square root of a positive number? Yes. And you're going to get two solutions, because if you add the square root of 4, or if you subtract the square root of 4, those are two different numbers. So guess what? You get two solutions, or two x-intercepts on your graph. So you can take the square root of a positive number. You'll get two solutions on your graph. And so down below it says, if the discriminant is positive, then you'll have two solutions. And I promised you a Kahoot, so that's as far as I'm going with this set of notes today. And we will start tomorrow doing some extra guided practice about the quadratic formula.